Okay. So the way we are going to work today, we are going to finish looking at the data manipulation functions that we saw yesterday. So yesterday we went deeply into understanding the basics of R. That was very good. And we had to go a little bit slowly to go deep into what we are doing and really understanding. Today we are going to go a little bit faster. What we are going to do today is go into the quickly over the manipulation data functions, and we then are going to go into the process of data cleaning and constructing our networks. Okay, so to start with, we are going to go in the R script from yesterday. That is in the Dropbox folder, intro to our part 1 of Monday. And so we are going to open the R script in our studio, if you all can do that. And if you want to follow, we are going to do the same as we did yesterday. We are going to have the R script for you in which you work. And I'm also going to be showing you what I'm getting in this format because I feel like it's easier for you to see this in this way. But they are exactly the same files. So if you are in your R studio, you can place yourself in line 580 and just run that part. Run that exact piece of code so that you have the data set loaded. That's what we're doing. So that you can follow with me and see and start playing with the functions if you want. If you prefer not to do that, you can absolutely just follow with me in the script that I'm showing you on the screen. Okay. Another thing that I want to mention, if at any point you have any trouble running through any error or have any questions, just please raise your hand and somebody from the group will come and help you. Okay. Okay. So for the data manipulation functions, we saw the important thing to notice here is that these are functions that work more or less in the same way, and they help you to do different manipulation tasks. So here we are not focusing on the details of what each particular function is doing, on the details of what each particular function needs as arguments. We are trying to understand more or less which are the types of data manipulation things that we can do. So just to give you an idea of what kind of things you can do. Yesterday we finished looking at the select function. So that allows you to just select, extract certain columns, the certain columns that you want for your data set. We are going to see many other functions. They all follow the same principle. You have a function like filter is the next function. And you have the function is always going to be filter or whatever the function name is. Then it's going to be followed by your data set, and then the condition or the arguments specific to that function. All of the details you have in your HTML and also in your R script. So the way to approach this is, again, like have a big picture understanding of what is there. And then if you have more questions or if you want to know more the details about how specific functions are working, then at your home institutions, you can go and more deeply see what you have in there. So the filter function allows you to extract not columns. Now we're going to extract observations. So let's say that you only want to have in your data set female respondents. So because we saw from the data exploration part that female is coded as 2, then we can just simply run the filter function and get only females. And you always, one of the basic principles that we have is that for every function, for every task that you do in R, you have to follow the same procedure. First, you have to know what you have, and then you have to run the function and always check what you did. So in this specific case, we saw that from the codebook, from the data exploration part, we knew that females were coded as 2. So that's how we know. We knew that in the data set we had females and males. And knowing that, then we run the function. And then we always check. And we always check how the function works with the data exploration functions that we saw yesterday. So it's always going to be the same thing. You run the function and then you check. In this case, with head, you can see that in the sex variable, everyone is 2 because you only selected the people who are female. See? And in that way, you always, every time that you run a data transformation, it's very good that you check that it worked in the way that you wanted it to work. Okay. Another very useful function is the arrange function. So that allows you to arrange in an ascending or descending order via a specific variable. And this is useful, for example, in this case, we have a variable that is the total number of nominations, the total number of friends that each respondent has. And so we can order them in an ascending or descending way. Again, it's the same. We run the function with the argument. We inspect what we got. And we see that if we order this in ascending way, we get all of the zeros first. So this is the variable .noms, total nominations. And we see that we start with the number 0 because that is the first number. That is the minimum amount of nominations that people could have. We can also use the same function and arrange things in a descending order. So in this case, we are going to use the same example, total nominations, but now in a descending order. And again, we are going to see what we got after we ran this function. And now we see that below total nominations, they are ranged from the maximum value to the minimum. So now all of the first ones are 10 because 10 is the maximum value. All right. We have another very important function, the function mutate. Mutate allows you to create new variables. And you can create these new variables in your data set, for example, by combining or doing arithmetic operations on other variables that you have in your data set. So for example, in here, we can create a new version that is the number of friends that you have who either smoke or you have had sex with. So it's just an example. And we run the function. we specify, okay, we're going to create this new variable. We give the name of the variable. And now, again, we check what we did. And you see that here at the very end of the data set, we see the new variable. And you can check, looking at the variables that it is constructed from, whether your code actually worked in the way that you wanted it to work. So this operation of always checking what you did is super important. Yes? It's the same thing. So all variables, data sets, lists, all of these things, everything that you can create in R is an object. So everything is an object, but objects are of different types. So a variable is a type of object. A data set is a type of object. That's the difference. So object is the very general category of everything that you can create in R. Can you repeat that part? Mhm. Yeah. So an object is a general class. Is a general yeah. An object is, you can create an object, and a variable is an object, but an object not necessarily is a variable. If that makes sense. Mutate. Yeah. Yeah. You can. Totally. So mutate. The nice thing about mutate is that it comes within the package that we are using for data manipulation. So it's just to have like a general flow of things that they all match. But you can do it in many different ways. There are always, when you code, like many different ways to do the same task. And it's not always that you have like just one right answer. Many times you will find that different people do it in different ways. And it's not right or wrong, it's just very different. But the cool thing about these functions is that you have a list of them. I wanted to give you a list of them so that you can pick from them what you want. Okay. Rename. Rename is another very useful function, and it allows you to change the name of an existing column. So for example, if we want to rename a variable that we have, p smokes, into smokes, we can do it with rename. We check and we see that the variable that before was p smokes, now it is smokes. Another very useful function is called summarize, and it allows you to get summaries of different of the data set itself, or you can create summaries by variables. So this is going to be very useful to explore your data and to have a very good sense of what you have in there. So for example, you can create, first we're gonna create a summary across the entire data set. So if you want to know what is the average number of friends with whom respondents have had sex, you can create the summary of these variable friend sex, and it's going to give you just the average in the entire data set. So this is a useful function that you can use for the entire data set for specific variables. And also, if you use it in conjunction with group by, that is the next function that we are going to learn about, you can create groups. You can group your data set into different categories, into different groups, and that is going to be very useful. For example, we can group your data set by grade or by a school or a different level of aggregation of different levels of variables that you want. And in that way, you can analyze and have a summary by groups. So say, and this you can do, this is a very intuitive way of doing it, a very efficient way to do it too. So first you group your data set. So say you want to get the mean of some variable by grade. So first you group your data by grade following the function. You can check that it has been grouped because when you inspect the element, you see that now it has 8 groups according to the grades. And then you can get the summary of a variable. In this case, the summary total nominations by grade. If you click on this new object that you created that is this summary, then you get a table in which you have the grade and the average number of friends nominated by grade. So you can see that this is very useful if you want to get a summary, if you want to see how different groups within your data behave, how they, what is the structure of them, what you have in your data. Okay. Now I'm going to talk about gather. Gather is a very useful function for social network analysis, and it's going to be because it's a function that you use a lot when you are transforming data to get a network. What you're doing with gather is transforming the data from wide format into long format. It will come together when we do the data cleaning process. But for now, I want to tell you how this works. And I'm going to go into detail in this one because this one is super important. So in the original data set, we have our data in wide format. So you see that for every respondent, 1, 2, 3, 4, 5, we have their friends in wide. So for every respondent, we have the friends in the columns male friend 1, male friend 2, male friend 3, and so forth in wide format. So you see it's wide. And now what we want to have is the same information, but now in just one column. So for every person, we want to know who his friends are, but in a column, not in just one column, not in these many columns. That is going to be important for constructing edge lists and like for constructing network objects. So with this gather function, we can do that. All of the details, again, you have them in there, but what you're doing basically is collecting all of the columns that have your nominations, and those columns, summarize them into a column friends that is going to have the IDs of the nominations, and friend ID that is going to have the names of the columns. So in friend ID, you are going to have male friend 1, male friend 2, male friend 3, and all of those. And in the column friends, you are going to have the specific ID, the identification of the people who were nominated for every respondent. So we can see that in an example. Here we are going to, in our data set, we run the function gather, we inspect what we got, and we are going to see that the columns of friendships have disappeared, and now we have the column friend and the column friend ID. And we have that for each respondent, we have the people who that respondent nominated in one single column. So that's going to be very useful later. We will see. Okay. We also have the join. Yes. We have the join function. And join function, we have many types of them. But here I'm going to show you the two that are most often used, that are full join and left join. And for that, I'm going to leave the data set that we were working with aside just for a minute. And I'm going to focus on a data frame that we are going to create in this piece of code. So we create a first data frame in which we have names, last names, and grades of 3 people. We create a second data frame, names, last names, and gender of other people, of the same people, of a combination of the same people and other people. So here we see that in the first data frame, we have the grade of these people. And in the second data frame, we have the gender of these people, but not the grade. So in these kinds of situations, you want to join data sets, because if you join the data sets, you get more information about the people who were in your data set. This will happen a lot in data transformation for social network analysis. So this is why I'm showing you these functions. And now I'm going to warn you that when you run this piece of code, you are going to get a warning. And I want to show you this, and this happened to me very naturally when I was preparing this code. And I thought, oh, this is a learning moment, because you are going to get warnings when you are working with data, and it's very good to know what to do when you get these warnings. So the warning that I got says, warning, column name joining factors with different levels coercing to character vector. And that seems very extraneous. That seems like a very weird message, and we wouldn't know what to do if we got that. Whenever you get a warning message, please be assured that the function ran. The function was executed. What the warning is telling you is that R thought something was missing, something was a little weird, so he had to either tweak something or is letting you know about what you did so that you can be sure that what you did was correct. Now, in this case, for example, it's very difficult, sometimes difficult to interpret really what the warning means, what the warning message means. So the recommendation is always to Google it, try to have an intuition of what happened. But if you cannot figure out quickly what happened, what you have to do is check very thoroughly that the function did what you wanted it to do. So, and you can do that with the functions that we saw for exploratory data, for exploring, for data exploration, better said. And you can do that. So you check very thoroughly, and if you didn't understand the warning message, it's okay. You move on. As you gain experience, you are going to understand the warning messages more and more. But it's important not to get caught too much into the warning messages that you get, because otherwise it's going to be, you can spend hours and hours and not really understand what they mean. But if you have checked thoroughly, I'm not saying be sloppy. If you check thoroughly that the function did what you wanted it to do, then you are fine to keep moving, keep going on. Okay. Another function that we will see is the function distinct, and distinct is going to allow you to eliminate duplicate values. So again, I'm creating here a toy data set that is a data frame. And here we see that we have 2 people who are exactly the same. It's really a duplicate value. So the function is just going to allow you to eliminate a duplicate value from your data set. That's going to be handy, again, when we work with this. So these are the basic functions that we are going to use. These are the very basic functions, and you have seen that you can do many different types of transformations with your data with these functions. Now I'm going to go into the data cleaning process. But I want to tell you that in this piece of code, I also added some new features because I know that some people might want to get now more efficient with their data. And so I added some new features like piping or how to construct for loops so that you can learn about these more advanced things. You can totally, absolutely, with the functions that I gave you and the first part of the code, you can absolutely do everything that you need for the data cleaning process. But these piping things and functions and for loops are things that you are going to encounter and that are going to make your code more efficient. So once you feel comfy doing the functions that we saw before, once you feel totally comfy with those, you can move into piping to make your code more efficient. I also wanted to show you this piping stuff because you are going to encounter it time and time again. It's becoming more and more popular. And so I wanted you to at least have an understanding of what it means when you see it. And so what it means, this symbol here, I don't know if you can see it. Yeah. This symbol right here, that is a pipe. And what it means, whenever you see it, the immediate thing to do is um, just replace that symbol by in your head by and then. That's all it means, and then. So what this means, if we see it in a very quick example, is let's say that we have this very simple function, mean of a vector that I just created only has the numbers 1 to 5, and if I run mean by my vector, it's going to give me 3. The pipe is exactly the same thing, but it's allowing me to pipe more things. So for example, here, I grab my vector and then I calculate the mean. So if you start verbalizing your code, you will see that you will understand better what is happening. It's the same thing. Let's see another example. When you have nested functions, you will see the utility of this. It's just a different way of coding, but because it happens so frequently, I wanted to show you what it means so that you're not completely confused when you see it. So for example, let's say that you have this example. Calculate the mean of my vector and then calculate the square root of that. So this is a function the way that we have learned it. And the way to do this with piping is take my vector and then calculate the mean and then calculate the square root. So as you see, every time that you have the pipe in there, it's going to perform a function on the last result you got. So in the result that you got right after the pipe, right before the last pipe. So you can see how these pipes work. If you are still confused about the pipes, that's totally normal. That's totally okay. I gave you this tutorial and you can go more in depth when you are in your home institutions or maybe, when you have a time to get a better understanding of it. And I gave in this tutorial a very step-by-step process of how you use pipes, how to learn how to use them. So if you want to become proficient on this, once you feel comfy with all the other functions that we saw, then you can go ahead and use the tutorial to learn how to pipe. And the same thing happened with for loops. For loops I'm going to show you is something that you will see a lot. A for loop is just going to allow you to do a task repeated times. So it's for repeated tasks. You will see this a lot in the code in the following days. So again, you can look at this tutorial more deeply, more thoroughly at your home institutions. But for now, let's just understand what is going to happen every time that you see a for loop. Every time that you see a for loop, it is saying for every element in this sequence, do this task. So the thing to understand here is first understand which are the elements that the loop is going to pass through, and then understand what the task is. And if you can understand, okay, which are the elements that I'm looping and what am I doing with them, then you can have a better intuition of what is happening when somebody presents this piece of code to you. It's not necessary that you right now can write for loops. That's not the point. The only thing is to understand what other people are doing so that you can get an intuition of what is happening. All right. So with that, we finish the intro to R sessions. Those are the basic functions, the basic elements of R. Now we can move into the data cleaning process. And for doing that, we are going to do exactly what we did yesterday. We have in our Dropbox folder in the second lab of Tuesday, second R lab intro part 2. And here we have 2 files. And it's exactly the same as we did yesterday. We get the R script. That's the file that you can run in RStudio. And you can totally run your code on it and play with it, you know. And then you have the HTML that shows you my code, what I did, what results I got, and it's going to help you be guided. Okay. So what are we doing when we are doing data cleaning for social network analysis? So data cleaning for social network analysis is the planning and executing of a series of steps to get your data from the raw format, whatever shape, whatever form you have it on, into network objects. And we are doing this because social network analysis tools only work with data that is in certain formats. So whatever the data that you have, it has to be turned into these specific data formats before we can analyze it with social network analysis tools. So that's what we're doing here. I'm going to give you a framework with which to work so that you can understand what the goal is, where we are going, and what you need to do to get into that goal, to achieve that goal. And the idea is that if you have this framework, if you know more or less what steps you have to take to get to this goal, it's going to reduce the uncertainty that comes with using R. It's not like somebody is telling you, oh, construct a network from the data set, and I don't know what to do. It's more like, okay, construct the network from the data set, but you know what steps you need to take in order to do that. The specifics are going to be different because everyone has a different data set, different needs, but the general picture, the general framework is going to be the same. Now I want to talk to you about the social network analysis tools. There are 2 packages that we are going to use throughout this workshop for social network analysis. The first one is iGraph, another one is StatNet. StatNet is really like a host of packages. It has several packages in it. We have already installed these packages that was included in the R installation code that you got the first day before the workshop. And so you don't have to worry about installing them or anything. The issue is these 2 packages are incompatible. So you have to work either with one or with the other at a time. You cannot work with both at a time. And so what complicates the thing is that for that reason, you have to, my recommendation, I really recommend to you not loading in your R library. Don't do library one and the other before you create the network because they are incompatible among them and they are also incompatible with the tidyverse and with the functions that we use to explore the data and to manipulate the data. So only load, some people have recommend to people, oh, put all of the packages that you are going to use at the very beginning of the code. No, don't do that. It's going to be very bad. So as you work, then you go loading your packages as you go, as you need them. And that's going to make your code more efficient, more cleaner, and it's going to make it work more importantly. So for this tutorial, I am going to use StatNet, but the process is essentially the same for both packages. So it's really not an issue. The goal, what we need to do for getting our data into a network. We need two types of data structures. First, a node data frame. That is going to be a data frame that contains all of the respondent IDs and the attributes that you want to include in your analysis. So for example, let's say in the data set we want to get the ego ID, the gender, and the grade. Yeah? So we want a data frame that contains this information, their IDs, and all of the things that you want to analyze, like the covariance, like all of the attributes that you want to analyze with social networks. Then you have to have another object, another data structure that is going to tell you about the relationships in your data. So what are the possible formats that you can use for social network analysis tools? You can use an adjacency matrix. We saw this with Jim a little bit yesterday. So an adjacency matrix is a matrix type of data structure, and it's going to tell you the relationship between every pair of nodes in your network. And you see the structure, no? All of the same rows, same columns. That's the structure. Another type of format that we can use is the edge list. So in the edge list, we only put the sender, so from whom comes the tie, to whom comes the tie. So for example, if we were to translate this into an edge list, it would be from Jim to Dana, because that's an edge that is present. So in an edge list, you only put the relationships that are present. So all the relationships that are present. And then you can also add, for some data sets, they have the weight of the relationship, or some other attribute of the edge. So it could be like the type of relationships, different edge attributes can go in here. You can also have the format of an adjacency list. And an adjacency list tells you for each respondent what edge they have. So for example, in this example, Jim is tied to Molly, so they both have the edge 1. Molly is tied to Dana, and so they both have the second edge, and in that way. So this is another format that you can use. The bipartite network. For bipartite network, you can have either this format. So for example, bipartite network is also known as two-mode network, when you have two different types of nodes. And for example, here we have types of clubs, and people who belong to those clubs. So two clubs are related if they share the same members. So for example, here we see that Leanne and Dana are in the baseball club. Jim, Leanne, Joe, and Dana are in the chorus. Joe volunteers, is the only one, and so forth. You see the idea. So this is the format in which you can get to a bipartite network. You can also get to a bipartite network with an edge list. And I'm not going to cover bipartite networks today, but I'm going to give you at the end of the tutorial the resources where you can find how to make them. Okay, but the process in general is going to be very similar. So what is the process going to look like? First, you want to inspect, you want to evaluate what you have, understand what you have in your data. Then you want to make a plan of what data transformations you need to go from whatever data you have to one of the structures that I just showed you, one of the formats. And then you are going to construct a network object utilizing the functions that I told you about just before starting the data cleaning process. And then you will check your work. So as you see, it's the same kind of framework. You always start by exploring the data, then you run a set of functions or a function, and then you always check that what you did really is doing what you wanted to do. Okay. So for inspecting or evaluating the data, the goal here is to identify what are your data manipulation needs. And here we want to identify two things. First thing, we want to identify what pieces in your data set are going to become the network. You want to identify where you have the IDs of your respondents, where you have your node IDs, where you have your attributes, what can be good attributes, what of your data set you can use, and what of your data set maybe is not really going to work as an attribute, even if it seems that it's going to work. So for example, this would be if you have a variable that has very little variability, if it varies very little, then it makes no sense to add it as an attribute if only one person is varying in that variable. You know, if only one person has a different has a different category. And these kinds of things you can find only by exploring your data. You can also find what pieces will be the edges of your network and what are going to be the edge attributes. So first you want to identify in your data set what can you use to construct your network. The second thing that you want to do is identify any issues that you might have. So for example, extreme nonsensical values, missing values, or issues at the structural level. So unnecessary columns. So for example, for people who are collating their own data, many times when you collect your own data, the data set that you get, for example, from Qualtrics, that is a very common survey software, is that you get the first rows as preview. They are preview rows that you use to test them, to test the survey, and you didn't realize that they were preview answers, but you get them anyway. So it's good to be aware of these kinds of things, of these little things, and you only become aware of those once you have a very good understanding of what you have in your data. Then we have the typical example of rows and columns in the wrong format. So first we want to really have a good understanding of our data. Then we make a plan. Then we come up with a task or a series of tasks that we can do to get from whatever we have to the network object. And so we make plans, okay, we are going to deal with these missing values. We are going to deal with these crazy values. We are going to get rid of them. We are also going to transform the data set in this way. We are going to use this function. And then see a roadmap that you can follow so that you can get from whatever your data is to the data network, to the network construct. And so the first thing that you need to do to start thinking about the functions that you will use when it comes to the data transformations is identify what type of format is the one that you will use. Adjacency metrics, edge list, which one of the ones that I showed you. So the majority of the time, people use edge lists. Those are the most efficient ones computationally. And so those are the ones that we are going to be using in the example that I'm going to cover today. But it's possible that your data is actually very close to being an adjacency matrix or an adjacency list, and that is very small in size. And so in those cases, you could already use the things that the format that you are very close to. You don't need to do a lot of transformations to get into an edge list. So it depends a lot on the data, specific data that you have. And then of course we need the node data frame. Then in the third phase, we construct the network object. And we construct the network object by implementing the plan. I'm going to tell you, realistically speaking, you are going to deviate from the plan as you realize that some things didn't work in the way that you expected. Maybe you didn't notice this, the function didn't work in the way you wanted. You are going to get stuck a little bit. But by having a plan, you are already like miles away. You are already having less uncertainty on what you are doing. And it's already giving you a good start. It's gonna take you less time than just being like when you are in front of a blank page and you don't know what to do. By thinking about what you can do, you are going to be already ahead. I'm going to cover this in a little bit. And then the final step is to check your work. Make sure that the network object makes sense, and I'm going to show you how to inspect your network so that you know, okay, this is accurate, taking into account what I saw in my raw data. I should have this number of edges, I should have this number of nodes, etc. Like different things of your network that you have to check you did correctly. So we are going to use the same data set that we have been using so far. In your code, you can run the same line that grabs the file from the Dropbox, and we are going to start. Some parts of this, I'm going to let you know right now, some parts of this I'm going to go a little bit quickly, and some parts of this you might not completely understand because sometimes it's a little bit convoluted to think about all of these data transformations, and you really have to understand the structure of the data. But this code is really annotated. I made it step by step. So if you feel like at some point you didn't get something was unclear, just go with the code and do it in your at your home institutions, or in the calmness of your cubicle, wherever, in a safe space. You you do it, you run it, and you work through it to understand it better. So if you feel like some part you didn't quite get today, that's totally normal, that's totally fine. But you have all of the elements to work through this and also apply the same principles here for your data set. I'm going to say right now, before I forget, in all of the tutorials, in this one and the intro to R one, I have at the very top of the script of this HTML my email. So if you run into problems, don't worry alone. If you feel like super stuck of it, or if something of the code is not making sense to you, you would like me to elaborate more or give you specific tips about something when you get stuck, don't hesitate to contact me. I am super willing to help you to elaborate more on specific things. Okay? So, having loaded our data set, we first begin by inspecting the data. And so, to do that, we just run the functions for exploring data that I talked about yesterday. So we see, what is the class of the data set that I have? It's a data frame. Okay, what are the names of the columns? Okay, here are the columns. Okay, let's see what the survey has, what the data set has with glimpse. That was one of the functions that we saw yesterday. And we say, okay, this is the structure of the data set. Now I am going to identify, ego, NID, and you usually do this with the code, along with the code book. Ego, NID is the ID of the respondents. Okay, so this is super useful for the network bit. This is the ID of the respondents. Now I have the nominations, the friends, the main friends ID for the first friend, for the second friend, for the third friend, fourth friend, fifth friend. Okay, these columns seem very important. And like that, you go and you uh, identify what elements are the ones that you need to grab for your network object. Then we see, okay, we have the race of respondents. That seems like another thing to take into account, the grade, the sex, etc. You expect the element. Then we see always like the first observations to have a better understanding of what we have. This is just like summary of what we did yesterday in the data exploration part. We get the tail again to understand the what the structure is. If anyone is collecting their own data, this head data set this head function is very important, because in this one with this one where you can see usually the previews. Usually there's a variable that is called distribution channel, and then you see the previews very clearly, and you see, okay, those are observations that I need to take out. You can also get the summary function, the summary of the distribution of each variable, and that's where you can really see if things make sense. Okay, so here, for example, this variable community, if you look at the code book, this is the school where they belong. So I say, okay, the minimum is 1, the maximum is 85. It looks like I have 85 schools. So then you can decide, okay, instead of doing the 85 schools, which are the schools that I really care about? In this case, for this particular example, we are going to work with just the school number 7, just to give you a heads up. But that's the kind of thing that you want to take into account, that you want to explore with this summary function. What do you have in here? What is going to be useful? Here also, because you have the minimum, the maximum, the range, the median, you can also explore like how much are different variables really varying? How much variance do you have? You can more or less have a sense of what is going on. Then you can make tables, again, for variables of your interest, crosstabs. So everything is things that we saw yesterday. Visualizations, they never hurt, you know. And once we have finished identifying, okay, these are the bits that are going to be my IDs, the IDs of the people, these are going to be my nodes, these are going to be the relationships. So here we saw this is a friendship network, so people nominated their friends. We already saw which variables are the friends. So once you saw that, once you have identified those things, you come up with a plan. Remember, this doesn't involve any code. You first just want to know, want to visualize, want to have a plan using the functions that I talked to you about yesterday, using those. And I'm going to give you later a couple tips of how to do that. You want to have a plan for dealing with the unusual observations and for the structure. And so once you get stuck and you don't know, okay, which function, I know more or less what I need to do. I know that I need to get rid of these NAs. I know that I need to perform these transformations, but I'm not really sure which function is the one that I need. A very handy way to get at this is if you go in the Dropbox of social networks and health, and you go to the intro to art folder. I put here, no, sorry. Yeah, intro to lab, I put here this called cheat sheets. And here, for example, this data transformation cheat sheet already gives you a summary in only 1 page, 2 pages of all the functions that I talked to you about. So if you want to see examples, you go to the piece of code that I gave you to see how they work. But if you just want to recognize which one, I don't remember which one, or to have more ideas of different things that you can do, you just go to the cheat sheet, explore it, and see what is useful to you, knowing what type of data transformation you want to do. So this is a very handy thing. I remember like I have them printed and like in my desk for whenever sometimes I forget, I don't remember which specific function was for doing this task, what was the name, use the cheat sheets. And they have like many different, they cover all the types. So for instance, if one of the ones that I thought here is not for you, you can find another one that is very, very similar, that is of the same type. See? I put cheat sheets for different things. So you have for manipulating rows and columns. This is also for rows and columns. I gave you a string, the string cheat sheet if you are working with text. If you are working, if you want to know just the basics, like this is another very handy one for creating all of the basic stuff that I covered yesterday. It's very handy for remembering it, for having a very quick guide that you can refer to if you need to. I also included the color one. That was Molly's suggestion. That was very good. And it's for when you have data visualization issues. We're going to get into those tomorrow, not today, but still know that this is going to help you with that if you need that. And if you run into data importing issues, you get the import cheat sheet. So that's how how you can get unstuck. If you see these functions, you see how you can work to get rid of your crazy values for constructing your network, for changing it into a format that the social network analysis tools are going to read. Okay, so we decided that we are going to make an edge list. Let's remember how the edge list has to look. It has to have 2 columns, the sender, the from ID, the to ID, that is the target, and the edge weight that we don't have. We just know the friendship, but we don't have a weight on the friendship, so we are not going to have this column. But it's good to remember, okay, this is the basic structure. So we need to get from the data set that we have right now into this structure. That's the goal. And so, okay, I'm gonna make a plan. And I am going to be very sincere with you. This is the plan that I made, and I'm including the code, like even the times in part of the code, even the times where I get stuck, where I got stuck, and what I did then, and how the process worked for me, so that you get an intuition of what are the kind of things that you have to do when you get stuck, because you are going to get stuck. Art is like that. I have not known anybody who has worked with art like just like smoothly. No. But this hopefully this is going to help you to have a good idea of how to get unstuck. Okay, so for constructing the node data frame, I have my plan. I have the construction of the edge list. I have a plan first because we are going to focus on school 7. I'm just going to filter by that. Then I'm going to move the nominations from wide to long. And I know, oh, the gather function is the one that is going to help me do that. Then I'm going to select columns, remove names. And the more specific you can be about the functions that you are going to use in this part, the better. Programmers do that, like statisticians do this. They call this the pseudocode. If they do this when they are programming, they have a first visualize in your head what steps you are going to do, and then try to do the coding part. Because if you start first, it's going to be more likely that you are going to get stuck. Then we are going to construct the node data frame. For this particular network, I'm going to exclude the isolates. That's not always recommended, but for sometimes people do the analysis excluding the isolates, and it was a little bit more challenging. So I still decided to include this in this example so that you can see how to do that. And so because we exclude the isolates, we are going to use the edge list as a starting point for creating the node data frame. This is because all of the nodes that we need are going to be included in the edge list. Because if a node is an isolate, it is not going to be included in the edge list. The edge list only contains the existing relationships. You need a from and a to. All right. And so starting from the edge list, I create my plan for the edge list, and seeing at the data set, I go, okay, I'm going to use this function to do this transformation, use this other function to do this transformation. As you can see, it's really like 4 steps per each one. Once you think about it. I'm not going to explain to you exactly because we are going to see in the example how that is going to work. Once I have my objects, so I have my edge list, I have my node data frame, then the third step is to create a network. And then in that specific step is when I'm going to start using the social network analysis packages and the social network analysis tools. And then I'm going to start adding attributes and like working more like with the network as a network object. So just to give you a heads up of the whole process, this is what it's going to look like. And after I add the attributes and I have the network set, I'm ready to go and perform social network analysis and all the fancier stuff. Okay. So now here comes the example in which we do that. We construct the network object. So we have the data set as we had it at the beginning. And we are going to create a first object that is going to be called the edge list. As we said, we follow the plan. Okay, I filter the observations because I only want to get the school number 7. I filter and I see, okay, this variable that is the school one should be 7, and I see everything is 7. Okay, I move to the next step. Step 2, I want to move the denominations from wide to long format. I knew that I had to do that with gather. So I use the gather function and I inspect the element and I see again, okay, here I have my respondents. I don't have the nomination columns, but I have at the very end of the data set, okay, here are the friends and here are the IDs of the friends. But here are the friends, okay? So I check and yes, it's gone from the wide format to the long format. Then I'm going to select just the 2 columns that I need. What do I need now for the edge list? Remember, the edge list was used the sender and the target. So I'm just going to need, okay, the ID of the respondent. That's going to be the first column. And the second column, the friends. Who is that person friends with? And I just select those 2 columns. And then, okay, I know that I can use the select function. I use it, check it, and I see, okay, this is it. I have the edge list. That's it. And I see, okay, we already saw that there were these weird values, the 99999, but we have to get rid of those. So by doing, in a previous step, I showed you how to get rid of the NAs just in this part. It's very easy, and you're going to learn how to do that on the way. Is not a problem. But now I have to get rid of the NNA values, and that's because NAs are easier to remove with those NA that are M functions. But now I get rid of the 9999s because I figure out when by looking at the code book, by understanding the data set, that those were not true values, but NAs. Those sometimes people code NAs as 9999, sometimes as a little dot. So you have to figure out, understand the data set to figure out which ones are true values and which ones are NAs. And so what I do to get rid of this is, again, I use the filter function. And by running the filter function, I see, okay, I don't have any more crazy values. And that's it. That's my edge list. We have the edge list completed. Now, for this next part, I am going to show you exactly as it happened, how I got stuck, how I got unstuck. So for the first step of my plan, I am going to construct now the node data frame. So if you remember, the node data frame was going to be a data frame. The first column were going to be my respondents, and the rest of the columns were going to be my attributes. So the gender, the race, those kinds of things. So I need a data frame with that information. Okay, because I'm not using the isolates, I just need the edge list. So what I can do from here to get the list of the nodes that I need to combine this one with this column, because the combination of these 2 columns is going to give me the complete set of nodes of this network. Yeah? And so because we learned the combine function, I use the combine function and I get a complete list of all the nodes that I want. Now, the next step, I wanted to use this thing to get rid of the repeated nodes, because when I combine, several nodes have multiple edges, and so when I combine, I have multiple nodes. So now I have to get rid of the repeated nodes. But as I was trying to do a step 2, I noticed that the distinct function only works with a data frame. So, and I had a vector. And as we saw yesterday, that's where the type conversion comes. So how do I solve the problem? I just convert the vector that I have as a data frame. And you see, these kinds of errors, when you run into errors because it was the wrong data structure, then you use the type conversion. And it's very common that you run into that type of thing. And then it worked again. Then, okay, I wanted to run into the next step. I wanted to join. Now I have the whole list of all the nodes that I want. Now I need to join them with the data frame where I have the attributes. So that with the original data set, where I have the information about the sex of these people, the race of these people, and any other attribute that I wanted to include. And so what I need to do here is I need to grab the list of the nodes and the data set, the original data set that I had, and join them together. So I can use a left join function. And as I was trying to do that, I noticed that before my nodes were called AH nodes, but the function join needs that the both data sets share the same name of the column that I'm trying to do the match with. So in the original data set, my respondents were called, or my nodes were called ego NID. And now I'm seeing that in the node data frame that I was trying to create, I had called them AHS nodes. So then what I need to do is rename them. Rename the columns so that the columns match when I'm trying to do the join. Okay, I have the both in the nodes data frame and in the original data set, the same name of the column. And now I can go ahead and do the left join. I do the left join and I check if it worked. And yes, it worked. I have the ID of the people and I have all of the different variables. Now, as you see, I have many ones here. So I don't know why I have many more observations than the ones that I had. So I got stuck again. And then I trying to understand is a process of going back and forth, trying to understand what happened. I realized, okay, I remember from exploring the data set that we had many schools. So probably the schools, and this was how my thinking was, why do I have so many ones? So it's probably that each school has the IDs of the nodes of the people who are from that school starting from 1. So let's check that. And I go back to the functions that allow me to explore the data. I group by school and I see, okay, this is each school. And I see that each school has somebody who is number 1. Okay, I have a problem. But I notice, I try to explore the data to understand when I get stuck, why am I getting stuck? What is going on? All of the schools have that, and I also see when I get the summary of the data, I also see that I really should have 457 nodes is the minimum and the maximum that I have. So if you see here, I have many more observations than that. So definitely this table is much, much more. And so that's the kind of thing, the kind of investigative thing that you have to see to realize what you are doing. Okay, so then what I need to do is just filter again my node data frame and just select the people who belong to the school number 7. And I do that again with my filter function. And I see, okay, I went back to what I wanted. Then I just need to, because we are constructing the node data frame, I just need to go back and select only the columns that I'm going to need, that are the node IDs and the attributes that I want. I want the sex, the grade, the race. Those are the only columns that I need. I select those, and here's my data frame. Here's the nodes. Here I have my nodes, the sex, the grade, and the race. And that's the node data frame. This was the process of the data construction, of getting from the raw data to the objects that I can get into a network. Now, this is very important, because I think it will happen to at least some of you. Whenever you are working with numerical IDs, as in this case, you have to make sure that they are sequential, and that the number of IDs that you have here match the number of nodes. If you go, I can't really show you here, but if you go if you run this, you will notice that the number of nodes that you have in the node data frame is 440. So you should have 440 of these ego NID when you create your node and data frame, the maximum value should be 440. But as we saw in the summary, in one of the summaries that we saw when we were exploring the data, the maximum value is 457. And what that means is that what is going to happen is if you don't have them sequentially from 1 to 440, from 1 to the maximum number of nodes that you have, the social network analysis tool is going to interpret that as isolates. You have 17 isolates, which is 457 minus 440. Is automatically going to create more isolates. So whenever you are working with numerical IDs, that I think that sometimes is going to happen because you de-identify people by assigning them to numbers many times, is that you have to be sure that they are sequential. And so here I'm giving you a piece of code of how to get this into a sequential. Yes. Exactly. Yeah. We need we need to do for both. We need them to match because if they don't match, if you don't match, so yeah, in the sequence here, it has to be sequential by the ego NID, by the first one, and in your node data frame, that's the most important thing. In the node data frame, they need to be sequential. Yeah, yes, yeah. The- then you won't have the problem because R is not going to think, oh, you have a gap between the 457 and the 440. That, yeah, then you won't have the problem. The problem is with the numerical, with the numerical IDs. It would not be an issue. It would not be an issue. Still, doing it with the numerical values is always better to have them sequential, even if you can transform them to character, because for easiness, for easy of recognition, and you know the labels when you label them, etc. Like it's easier to work with them if they are in a sequential manner. You don't have to think about the 427 when you're checking more things more deeply, you know. But when you have names, that's not an issue. The names usually are labels that um, have substantive meaning, so it's easy to recognize the people. But when you have the numbers, then it's more difficult. Then you want to have it sequential. Mm-hmm. Um, so I'm showing you here how to do this, how to get the sequential and in range, like have the whole range of IDs for the edge list and for the node data frame. And so we are going to create a new variable with the numbers, the nodes in the node data frame sequentially. So we create a new variable, new ID, that is going to be 1, 2, 3, 4, 5, 7, 5, 6, and up to 440, and it's going to be matched to the ego NID. So now for the node data frame, we just have to select, we already have the new IDs. What we need to do now is change this on the edge list. That's the most challenging thing. But I'm showing you here that if you use left join, if you use the functions that we have already learned, you can achieve this easily. So we are going to join these to the node data frame and the edge list so that I get the new ID now for the ego NID that I have in the edge list. And if I join these two data sets, then I get this. And I see that I have the new ID for the ego NID in the edge list. So now I just select the columns that I need. I know that this is going to be the new ID, and this used to be the previous ID now of the receiver of the edge list. And so what I keep is the new matching, and the column that I had of the receiver. But this receiver column is with the old IDs. So I need to change this one too. And so again, like I rename so that I can make the match between data sets. I match the data sets, and it's essentially the same process, but again, now for the receiver. So I have now the sender, and now I have the new ID that I just matched to the receiver from the previous edge list, and I can do the match very easily. And then I just select the columns that I need. For purposes of clarity, I just rename so that as this is sender, this is target, and I have my new edge list. So you see here that it's essentially the same, but what I did was change the identifications so that they go from 1 to 440, and I don't have any problems. So the final edge list and the node data frame are ready. And now we're ready to construct the network itself. And so now we need to load the package, the social network analysis package. That in this case is a StatNet, but you can also do this with iGraph. So for constructing the network, I'm gonna create an object, HSS network, and I'm going to use the function as network. Then I combine the edge list and I tell the function, okay, my vertices are going to be the nodes, that is like the node data frame. So I just assign them there and I inspect the network. And sure enough, I have the vertices, 440. I see the total number of edges that should match the total rows of the edge list. And I see that I don't have any more attributes of the vertices than their names. And this is worrisome. It's not worrisome, but we will deal with that because what should happen, what we want to happen here is to have as the attributes the sex and the race and the things that we have as attributes in our nodes data frame. But we can assign the attributes very easily, as we will see. We can also get a quick plot of the network, and we see our first plot of a network object. And we see here the plot, exactly what we expected. We don't see any isolates, as we knew, because we are working just with the edge list. And then now we can add the attributes. So to add the attributes using a StatNet, you have to use the function set vertex attribute. And we are going to tell, okay, set a vertex attribute in the object, HSS network, our network. We are going to call this attribute gender, and we are going to grab the attribute from the sex column of the node data frame. So this is why it's so important to have the node data frame with all the attributes, because that's where you grab them from to set the vertex attributes. We do the same with race. And now if we inspect the network object, we see that now it appears here. Okay, we have as vertex attributes, gender, race, and vertex names. So that's how we see, okay, we have the attributes there. We can explore we can access the vertex attributes with this operator. So just to let you know. And then we can assign colors. I'm just doing this to show you how you can use your node data frame to assign these attributes. But really, like the things that are beyond creating the network, once you have already created the network, are more explained in other tutorials that I'm including at the end of this tutorial. And some of these things, data visualization things, are things that you are going to cover tomorrow. But so that you can see how we do things and how you can add attributes here using the node data frame. The node data frame I'm using here, I'm creating color vectors, and I'm just telling, okay, create a color vector for the distinction female, male, and I'm just going to use the sex column from the node data frame. And if it's 2, I'm going to assign it red. If it's not 2, I'm going to assign it gray. And if I run this, I can do the same thing with race. If the race is 0, I'm going to use gold. If it's 1, another color, and this is where the color cheat sheet comes into place, because you can see the names of the colors in that cheat sheet. So that's how you can use it. And once you have this, you can set the color, the vertex attributes with those colors. And if you just a very simple plot, if you use those vertex attributes as the vertex color, now you see how that is playing. Now, if we color by gender, we see the coloring. We see the vertex attributes coming into place. You can also assign network measures as attributes, but I'm going to leave that. I'm just going to tell you that it is possible, but I'm going to leave that because that is going to be covered in future workshops. But just to give you an idea of the kind of things that you can do once your network object is already created. Finally, you can save the network. It's already clean, it's already finished, and you can save it running this function save. And it's going to save the network object, the network constructed, wherever your working directory is. So this is the importance of setting the working directory, getting the working directory that we saw yesterday. If you don't find the saved object that you have, you can run the function get working directory to figure out where it is if you're unable to find it after running this piece of code. And so that's exactly the process that we are dealing with. We went from the raw data to the network object already created. That's using the framework, using the steps that I gave you. That's exactly what we were trying to do. I hope that really this was something helpful for you, that you can use the framework, that you can use the functions, the cheat sheets. There are many other resources that you can use. You can always Google. There's a very good page that is called Stack Overflow that you can use if you run into R problems. You can use the cheat sheets. You can use Code Academy. There are different online sources where you can learn how to code if you're having too much trouble with R and with the data manipulation stuff. As I said, I put my email here in case you want to contact me for any questions, anything that you would like me to expand on, or any help. If you get super stuck and desperate and don't know what to do, don't worry alone. I'm here. And that's it. Thank you so much. Do we have any questions? Yes. Edges, no. Like in the edge list, you only have edges that are present because you need to specify the center and the target. I'm not actually sure in the last. Uh, I just shut it down, like I just closed it. But if you see in the HTML at the very end, there's a PDF where you can see how to add and manage the network and do things to the network once you have it created. I'm not entirely sure if you can add isolates. My sense is yes, but that PDF is exactly the place where you would look at that. Mm-hmm. Yeah. All right. Thanks so much.